In this presentation, serial and parallel pumps experiment, which is the 8th experiment of the machine laboratory, is going to be examined. The objective of this experiment is to develop pump characteristic curves for a single pump, 2 pumps in series and 2 pumps in parallel by measuring head and flow rate using the experimental apparatus. To develop theoretical pump characteristic curves for pumps in series and pumps in parallel, experimentally tried single pump characteristic curve. To compare the experimental and theoretical pump characteristic curves, to compare the experimental and theoretical pumps characteristic curves for pumps in series and pumps in parallel. A pump is a turbo machine used to transfer liquids from one point to another. For this purpose, pumps use mechanical energy. The pump works on the liquid to increase its energy to a higher energy level or entropy and consequently its pressure. Most pumps work on the basis of a rotational motion. However, some pumps have also been developed that operate by linearly moving their components, increasing liquid energy. The source of energy for pumps is usually a fuel engine or an electrical motor. The important point about the pump is that this machine is not a means of converting the form of energy, but directs the energy in a predetermined direction. Of course, no pump has 100% efficiency because a portion of the energy is lost due to vibrations, noise, and heat, etc. Water naturally flows downwards due to gravity, so humans need to use a mechanism that raises water from lower levels to be utilized for everyday life, washing, hygiene, food preparation, or special uses such as agriculture, animal husbandry, and industrial application. The first sign of the invention of the pump appears to have belonged to the Egyptians around 200 BC. 2000 BC. The name of this tool is shaduf, a cup tied to rods and ropes to draw water from deep wells. You can see in this figure the first pump in Egyptian 2000 BC. It calls shaduf. Between 300 and 100 years BC, the ancient Greeks made significant advances in pumping. The invention of the water wheel occurred during this period and was used for irrigation. Archimedes also invented the screw pump at this time. A power pump was also invented in Egypt during this era. The pump operated manually using a cylinder and piston system to draw water. For several centuries, pump technology did not advance and pumping systems of the past continued to be used until the Enlightenment. However, since about 500 years ago, the study of water machines was again considered, which led to the emergence of and development of modern pumps. You can see the Archimedes invention, screw pump. Whereas turbines extract the energy from the fluid, pumps add energy into fluid, increasing the energy possessed by the fluid. The pump has been developed to transfer fluid from one point to another with a higher pressure energy level. So, a pump increases the energy of a liquid. Pump moves impellers by taking electrical energy from an external source. This movement causes the momentum to transfer to the surrounding fluid and move the fluid. The turbine is used to convert the kinetic energy of a fluid with high speed or pressure into mechanical energy for the rotation of the rotor and shaft, and ultimately to generate electrical energy. Hence, the turbine reduces water energy. Water enters the turbine blades very quickly. The blades start moving with the rotor. The rotor is connected to the shaft, which itself is connected to a generator to generate electrical energy. There are two main pump types: positive displacement pumps, pistons, plungers, diaphragms, vanes, screws, lobes, which have a fixed flow rate per stroke or revolution, and turbo hydraulic or kinetic pumps, centrifugal pumps, which convert fluid kinetic energy into pressure. The design of a centrifugal pump has the water entering the low-pressure center of the impeller. The vanes then lead the water to the higher pressure region to the casing. The casing is designed with a gradually expanding spiral shape so that minimum loss occurs in the transformation of kinetic energy to pressure. The pump receives the water at a low velocity on the interior edge of the set of moving impeller vanes and discharges it from the outer edge with kinetic energy sufficient to raise it to a desired height, and through the gradually expanding spiral passage transforms the kinetic energy into pressure. Pumps are used to lift water up or to increase the energy so that the water can travel farther. The slab determines the head or flow characteristics of centrifugal pumps operating at a single speed. A single centrifugal pump, two similar centrifugal pumps operating in parallel and in series. Recall the total head is the difference between the total energy head at the outlet and the total energy head at the inlet, neglecting the small differences in velocity heads, as shown to be the following equation, or in other words Bernoulli equation. In this equation, subscript 1 and 2 refer to inlet and outlet sections. A sub P is the pressure head produced by the pump, and A sub L is the energy loss due to friction and pipe fittings. By conservation of mass, V sub 1 equals to V sub 2 if the pipe diameters are equal at the inlet and outlet sections. When two or more similar pumps are connected in parallel, the head across each pump is the same and the total flow rate is shared equally between the pumps. Qp over N, where N is the number of pumps in parallel. For identical pumps in parallel, the pressures at the two inlets and outlets are identical, and the maximum head the two pumps can deliver is no greater than for a single pump. Theoretically, the flow rate is doubled, although in practice this will not occur due to losses in the piping systems. Total head, using outlet not manifold, is determined in the same manner as for the single pump. The theoretical curve for the parallel pump configuration is obtained from the single pump data by multiplying the flow rate by 2. When two or more similar pumps are connected in series, the same flow rate passes through each pump and undergoes a head boost of total head divided by number of pumps, which is A sub P over N. Therefore, the series configuration of two identical types provides a pump characteristic of twice the head as for a single pump. The theoretical curve for the series pump configuration is obtained from the single pump data by multiplying the head by 2. This doubled head is plotted with a measured flow rate. For a pump, the efficiency can be found by this formula. Output power is determined experimentally. Input power should be given in the manufacturer's specifications for the pump. An important objective when selecting a pump for an engineering system is maximizing the efficiency for the desired flow conditions. Okay, these are the elements of serial and parallel pump experiment. You can see in this figure feed tank, sensors, which is vacuum manometer, another sensor, first pressure manometer, second pressure manometer sensor, flow meter, ball valve, digital multimeter, pump 1 and pump 2 switches, main switch, emergency button, and these are pump 1 and pump 2. Also, there is a schematic view of serial and parallel pumps experiment setup. For single pump setup, valve 3 and valve 4 should be opened because the first pump is started. valve 3 and valve 4 should be opened. Valve 1 and valve 2 should be closed. For serial pump setup, valve 2 and valve 4 should be open, 2 and 4 should be open. The flow follows this line in serial pumps. First and third valve must be closed. And for parallel pump setup, valve 1, valve 3 and valve 4 should be open. The water flow this piping rod, this one and the other one this. For this experiment, the pressure is read from the manometers instead of head, since in university conditions the head or height of the water which is elevated by pump cannot be measured. Also, the capacity of experiment setup is not enough to observe head level. Thus, we move forward in calculation by using volume time method, which is mentioned in lab manual, with measuring the pressure values. Okay, let's make an experiment. First of all, we make sure of electrical connection. Then we open the leakage current relay and the fuse. We turn on the main switch and the digital multimeter panel turns on. Okay, there are 4 valves in this experiment setup. If a valve is perpendicular to the pipe, it means closed. Now all valves are closed. You can see the feed water tank. Sorry about the water color. This is not clear. The water level should be proper in the tank. This is the first pump. Now you can see the sensor which measures the vacuum pressure level and it links to the vacuum pressure manometer. The second sensor measures the first pressure level and it connects to the second manometer. The last one measures the second pressure level. It links to the second pressure manometer. Also, it is the first pump and the second pump and flow meter you can see. These are the pump starting switches and digital multimeter, but in this experiment digital multimeter is not used. Okay, firstly a single pump setup should be done. The water flows this way for the single pump setups. The first pump should be open. The first valve must be closed, which is this one. After leaving the first valve, the water reaches another intersection. The second valve must be closed, since the first valve is active, and the third valve should be open. It is opening, right? Then fourth valve must be open always to let the water passing through the pipe and reaching again in the water tank. For the single pump, the first pump is started. Alright, the water in the tank is moving now. Since the first pump is active, third valve active, the flow meter reaches the specific level and pressure is changing. Now, the measurement is done with adjusting the flow meter or flow rate level, and time is counting now. You can adjust the flow rate by using the fourth valve. If the flow rate is decreased, the pressure increase. This is the maximum flow rate level. It means that the minimum pressure level. the pressure level is decreasing now. This is the single pump setup. Let's make the serial pump setup. For the serial pump setup, first valve is again closed. The first valve should be closed. After leaving the first pump, we don't want to reach the flow meter, so the third valve also must be closed, but the second valve should be opened because pumps should be in series, and of course the fourth valve is open. You can see the motion in water for the serial pump setup. Then the second pump is open. The second pressure manometer is changing now. The flow rate also can be adjusted. We can adjust the flow rate with using fourth valve, and all measurement data can be done with using flow meter adjusting valve and timing and pressure reading. Okay, you can transport the water to the higher level with serial pumps, but in this experiment setup the pressure values are read to find the head. Before we mentioned it, the experiment setup is not enough to measure the head or height. Okay, let's make the last setup, which is the parallel pump setup. In parallel pump setup, the first valve must be opened to make the parallel way. It must be opened. The second valve should be closed because it has been just used in series pump setup. The third valve and fourth valve are opened also. Opening the first pump, the pressure is increased and the water in the tank is starting to move a little bit. You can see the motion in water because the first pump is active now. And after when the second pump is started, the flow rate of the water reached the maximum level. You can see right now the flow rate reached the maximum level, and you can see the motion of the water is increased. The motion of water is increasing with parallel pump setup. This is the parallel pump setup. Again, all measurement data is read with using flow meter, time and pressure. More amount of water can be transferred with parallel pump since the flow rate is increased with the parallel pump setup, as you can see. After all setup is done, pump switch, all four valves, main switch, current relay and fuse are shut down, and lastly, electrical connection is cut down. Okay, thank you for listening. Serial and parallel pump experiment. All necessary parameters will be given to you. To do calculations in the experiment, please read the laboratory paper carefully. All formulas you need are in this paper. Be careful with the unit while doing calculations.